Imagine having a personal tutor, one that's available 24/7, that intuitively adapts to your needs and speaks your language. This is the promise of AI in education, and is something that I work on at Google DeepMind, building a system called LearnLM, an AI tutor designed to complement human teachers. But how do we build a sophisticated system like an AI tutor using language models? We're going to explore the key stages of the machine learning development pipeline and how we apply it to build a system like LearnLM. Building an AI system is a systematic process. Assuming that you've already formulated your problem statement and you know who your target users are, you would begin by gathering some data. This data has to be cleaned or pre-processed before we can use it to train a model. Alternatively, you might use a pre-existing model here. We then fine-tune this model, which means specializing it for a particular task. Then you would evaluate it before deploying it to real users and monitoring how it performs in the real world. Now we're going to look at each of these stages in more detail, starting with the data. You may have heard about how large language models like Gemini are trained on large amounts of publicly available data. This gives them a broad general knowledge and a deep understanding of language. But if we're building a system for a specific task, then we also need data relevant to that task. To build LearnLM, we recruited expert human teachers to create transcripts of conversations that demonstrate effective teaching strategies. If we are building an AI tutor to serve students in Nigeria or in Tunisia, then it's important that that system reflects their reality. This might mean speaking local languages, or being adapted to local curricula, or sensitive to different cultural contexts. This task of gathering diverse local data is both a big challenge and a massive opportunity. The data that we collect at this stage is often called raw data. The reason is because it's often messy, and it might be in the incorrect format or contain biases. So in order to make this data useful for training a model, we need to pre-process it. Pre-processing involves cleaning up the data, removing things that we don't want, like emojis or typos. Then, as responsible researchers, it's important that we carefully review the data and filter out any harmful or biased content. Once we're happy that the data is of high quality, we can format it and tokenize it. Tokenizing means breaking the data up into small units that the model can understand. Once we've completed pre-processing, we have what's known as clean data. Using this clean data, we can train or fine-tune a model. Now, training a model from scratch can be a very resource-intensive process. It often involves large amounts of data, lots of computing power, for example, in the form of GPUs or TPUs, and it can use significant amounts of energy. So often what people do instead of training from scratch is to use an existing model, also called a pre-trained model or a base model. This could be something like the Gemma family of open models. To build LearnLM, we use Gemini as the base model. These base models might have a good general knowledge, but they don't necessarily know how to do our particular task. And this is where fine-tuning comes in. Fine-tuning means specializing the model for a particular task. It usually involves two separate stages. The first is called supervised fine-tuning, or SFT. Supervised fine-tuning involves continuing to train the model on a small amount of very clean data. The objective here is to train the model on how to do a particular task, particularly the format and the style. For LearnLM, we used the tutoring conversations we gathered at the data stage to teach the model how to teach. The next step in fine-tuning is reinforcement learning from human feedback, also called RLHF. RLHF is the process by which we use human preferences to make a model both more helpful and more harmless. For LearnLM, we used RLHF to teach the model how to be patient with struggling students, to avoid using complex jargon, and to encourage students to reach their own conclusions rather than giving them the answers. Once we've fine-tuned a model, we can then evaluate it. There are many ways in which we can do evaluation. One such way is by using data or tasks that are specifically designed to probe for certain capabilities or weaknesses in the model. These are often called benchmarks. Another category of evaluation is human evaluation. Here, we use real people to interact with the model and assess how well it performs the task. Some examples of human evaluation include A/B testing, where a person interacts with two different models or two different versions of the same model. And another example is red teaming. This is where people deliberately try to make the model fail, and this is often used for safety evaluation. For LearnLM, we used human expert teachers again to assess whether the model is able to use effective teaching strategies. And we also conducted safety testing to minimize the chance of the model causing harm to any users. Once our evaluation criteria have been met, we can deploy the model. But the process does not stop here. It's very important that we continue to monitor how the model performs in the real world, looking at system logs to catch any issues and to gather feedback from users. And this feedback feeds back into the machine learning development pipeline and allows us to build the next version of the model. Let's recap. To build LearnLM, we gathered tutoring conversations from expert teachers. We cleaned this data up and used it to fine-tune a base Gemini model. We used supervised fine-tuning to teach the model how to teach, and RLHF to teach it how to be a good tutor. We evaluated it using benchmarks, human evaluation, and also safety testing. Then we deployed it, and we continue to monitor how it performs in the real world, and this allows us to iterate on the model. LearnLM is an AI tutor, but the same pipeline applies no matter what system you're trying to build. Whether it's an AI advisor for local farmers, or a system that sends healthcare information over SMS, or a chatbot to interact with government services. The key is adapting each stage of this pipeline to your particular problem. But it's not just about the task. It's also about the linguistic, cultural, and infrastructural realities of the region that you're working in. And building local capacity to manage this pipeline is essential. So to summarize, we've spoken about the machine learning development pipeline, which consists of the stages of data collection, pre-processing, training, fine-tuning, evaluation, deployment, and monitoring. Each step of this process is essential for building a specialized and aligned AI system like LearnLM. And understanding the steps of this pipeline will empower you to build the next generation of AI systems to solve real-world problems.